Just one line. I'm going to measure this DLI. So this is 884 millimeter. Or for past test calculation, we can use Pythagorean theorem. Using Pythagorean theorem, if this is our triangle and angle is 45 degrees here, this is B, this is A, this is 1.25 meters. Solving for A is equal to 1.25 times sine 45 degrees. So therefore, A is equal to 0.884 meter. So this is 1 to 50. So I am going to use this distance. Let's say 0.884 meter. Using the node cursor, highlight this node, then go to geometry, translational rivet, then look at the global axis. Our direction is along G and it is negative, so the distance is negative 0.884. 4 steps, then click OK. Now highlight these 4 nodes. We would copy the nodes to the right, so it would be positive. Geometry, translational rivet, x-axis, distance positive 4.5 meters. Using the beam cursor, highlight the beam one by one. Highlight one beam, then press Ctrl on your keyboard while clicking the rest of the beams that we want to highlight. Next, go to beam on the ribbon toolbar, then click intersect beams to intersect that beams. Click OK, then click OK again. Now delete the beams as shown. These are no longer needed. Again, highlight the nodes. If nodes, use node cursor. If beams, use beam cursor. Geometry, translational rivet again. This time our global direction is Y. The distance is 2. Then click the length steps and then OK. Again, highlight the beams, then go to beams, then intersect beams. Next, copy this node in the negative J direction with a distance of 10 meters. Extend this line. Since this truss has no property assignment yet, then we can isolate this very easily using attributes. To do this, go to select attributes, missing property, then missing property again. Click, then right click, then new view. Click OK. To check the distance of web member whether it conforms to our drawing in AutoCAD, go to Utilities, Node Tools. In the left side, click the drop down, then select node to node distance. This time, we can measure the node distance. So it is 1.25 meters. To remove the distance, just click the node tools again, then click remove node to node distance. Now let us do the remaining web members. Now let us assign properties. Click this for web member. By using drag line as our selection mode, position your mouse cursor here as shown, then drag it to select all web members. Assign to selected beam, then click assign. Next, highlight this one for bottom chord section. Go to attributes, missing property, missing property. Assign to selected beams, click assign. To mirror this hip truss that we had just created in staad, from this position to this area, then to this area. First, we will create a node in this area which is 3.5 meters away from this node. Take note, the distance from this node to this node is 7 meters. So half of it is 3.5 meters. We may position our node somewhere here. Let us say negative 10 meters from this node and 3.5 meters from here. So using node cursor again, highlight this node. Oops, we need to highlight only one node. Right click in the display screen, click copy nodes. Then right click again for the second time. Then paste nodes. Now in the dialog box, fill this up with negative 10, 3.5, then click OK. Now let us start copying this by the use of mirror command. So using beam cursor, highlight this truss, go to geometry, mirror. Our plane mirror is YG. Now locate the node on plane. This one, click OK. Again, highlight these trusses. Go to geometry, mirror. Mirror plane is XY. Node on plane is this one. Click OK. Now delete this node. Go to view, then click display the whole structure. Next is to model this H2 truss here. Using beam cursor, select these two beams. Right click in the screen, then click new view. In the left side, go to geometry, click add beam, then connect beam. Spacing of web member is 1.3 meters. Using node cursor, highlight this node, then copy 3 steps of this node to the left, which is negative 1.3 meters distance. Node cursor again. Highlight these 3 nodes, go to geometry, translational repeat, or there's another way by using reference point, and select this beam. Right click in the screen, click copy. Right click again, then click paste beams. And in the dialog box, click reference point. We can select any of this node, but in our case, we select this and click OK. Click here, click OK, click here, click OK, and here. Highlight all, Go to beams, then click intersect. Next is the cracker rafter. This rafter here, the distance of this rafter from this truss is 12.32 meters, as well as this rafter here. Go to top view. Let us isolate this area here. To do this, highlight the area like this. Right click and click new view. Go to front view. Select the trusses. Right click, then new view. Go to isometric view. Using node cursor, copy these two nodes. Go to geometry. Translational repeat. Global direction X. Distance negative 2.32 meters. Length step Okay. Highlight this one node here again. Geometry, translational repeat, global direction is G. Distance negative 4.5. Length step, then okay. Highlight these beams. Go to beam tools, click intersect beams. Then delete the beams. Again highlight the node. Geometry, translational repeat, global direction Y, space 2 meters. Okay. Highlight the beams. Beam tools, click intersect beams. Delete these beams. Go to geometry again, click add beam, then connect beam from this node to here. Go to property in the page control to assign property of this rafter. Highlight this section property. Assign to selected beams, assign. Now we are going to rotate this rafter clockwise by 90 degrees clockwise. Highlight rafter, go to geometry, generate rotate, angle is 90. Node 1 is this one, node 2 is here. Click copy, then click OK. Now let us view the whole structure. Go to view and click display the whole structure. Now let's go to top view. Highlight this node. Geometry, translational repeat, global direction G, distance 3.5 meters. Click length steps, then OK. Highlight these two beams. Go to geometry, mirror, mirror plane YG, node on plane, OK. Highlight the 4 beams. Go to geometry, node on plane this one, then click OK. Now here copy this beam 2.32 meters to the left. Right click, click copy, right click again, then paste beams. X is negative 2.32 meters, then click OK. Now let us go to isometric view. Highlight the two beams. Go to beam tools, then click intersect beams. Using node cursor, we will copy this node upward. Go to geometry, translational repeat, global axis is Y, 1 meter distance, click length steps, click OK. Now highlight this rafter. Go to geometry again, generate rotate. Angle is 90. Node 1 is the top node, node 2 is the bottom node. Click copy, then OK. Delete this beam. Now let us copy the second floor beams and paste above to serve as roof beams, because we have roof beams here. To do this, let us isolate first all of the trusses and hide them so it wouldn't be confusing. Now go to left view, go to properties in the workflow feeds control. In the right side dialog box, select L3034 section. Go to select, then click inverse. Right click in the display screen, click new view. Again select L3034 double angle. Go to select, then inverse. Right click again and select new view. Now select the beams in the first floor. Go to isometric view. Right click in the display screen, then click copy. Right click again and paste beams. Then click reference point. Select node, then click in this column, then click again. Display the whole structure. Go to the left view, select the trusses and columns like this. Right click, then click new view. Go to isometric view. Select everything. Go to beam tools, click intersect beams. Now let's isolate and hide trusses. If we notice, the trusses here are deep seated, and we are gonna offset these trusses upward by, let us check here in our sketch how much we need to offset the trusses to remove this unsightly 3D view. So this is the stake model here in staad, this is the column, and this is the top chord, and their connection is this node here. If we look at this in AutoCAD, the point of intersection of column and the top chord is the node here, right? And if we look at this in 3D render mode, the outcome is this one here above. This is the node, which is the intersection of the top chord and column. So the bottom chord should be offset above by, let us measure this. 127.44 millimeter. Meaning, if we bring this above, this will be in this position, like this, right? So we need to offset this by 0.12744 meter. And let us set up this in staad. From here, go to specification, click beam here, then click offset here, then start is selected here. Type 0.12744. Click add. Click beam again, offset, then this time select end here. Type again 0.12744. Click add. Now to apply this to our model, isolate all the trusses. Go to properties, then select the columns here. Go to select, then select inverse. Right click, then click new view. Select these beams, ensuring all the beams highlighted. Go to select, then inverse. Right click here and select new view. This time go to specification here, then select this one, the one that we had just created a minute ago. Select all of this, assign to selected beams, then click assign. Select the other specification. While the trusses remain selected, click assign to selected beams, then click assign. Then display the whole structure. To display node numbers, right-click here in the display area, click levels, then check the node number checkbox. Or on our keyboard, press Shift plus N. If you want to hide node numbers, just click again Shift plus N. Now I would like to save a copy of this model in a folder named Truss Design. Go to File, click Save As. Write the file name as Truss Design. Let us browse the folder named Truss Design. Just highlight the folder and don't open. Then click Select Folder. Click Save. Next, now let us give support of our trusses. Go to Support in the Workflow Page Control panel, then click Create. Click Fin, then click Add. Click Create again to add support specification. This time, click Enforce But. Here, we have release specification. We would allow movement along X direction. So, we would select FX. But we would restrict movement along G and Y direction, so we would leave this to unchecked. We would also allow movement about G and about Y axis, meaning the component doesn't resist moment about G and moment about Y. So we also select these two. Then click add.